Okay, I'm going to try again because it froze up, and it may just be that my computer can't handle more than 8 minutes. So this is part 2 of this. I'm not sure where I left off, but I was doing the area of a square, and where the areas are squares, and this would be my square, area of square is side squared, y2 minus y1 is the side. This is what we'd be. By the way, if you look at this, these two are the same, but this is 1/8 pi smaller. 1/8 pi is about 1/3, and it was kind of interesting if you take this and put that, this is about 1/3 of the area of this whole piece of paper, roughly. Okay, so that's the basic idea. The hard part for you will be that they will sometimes ask you to come up with different shapes that they're using as the cross section, and they also make things a little more challenging in other ways. So let me show you 2 problems, and we'll see what we can get done. If it freezes up again, I might post a 3rd video. Let's say we had y equals 6 minus x, y1, and y2 is x squared. And we're told that we want to find the volume of semicircles perpendicular to the xy plane formed between y equals 6 minus x and y is equal to x squared. Okay. Well, what we'd have to do first of all is solve this. I'm going to do this pretty quick because of the time factor. If you graph this, graph it on your calculator, you find out that this is 2, this is 3. You could also set those equal to each other, factor it, and that's what you would get. This is our shape. I want to put semicircles in here. Well, the area of a semicircle is 1/2 pi r squared. My r is y2 minus y1 over 2, so this distance here. And my volume then will be 1/2 pi times y2 minus y1 squared over 2 squared dx. And in this case, I should have put y2 and y1 in. I'm going to pull this out. That's squared times 2, 1/8 pi. And this would be y minus, well, it's actually x squared. It's kind of backwards, but because we're squaring it, it won't matter. X squared minus 6 minus x squared dx. And if you try that, you will come out with 625.6. By the way, they oftentimes will do that. It's actually on your calculator, it would be 104.166. It's 104 and 1/6, or 625.6. Okay, if I was to change the semicircles to squares, basically it is almost the same thing. Volume is, the side is y2 minus y1. Y2 minus y1 squared dx, or just this right here, x squared. Oh, by the way, this would have to have a, I'm sorry, this would be 625 pi over 8. This one, x squared dx, works out to be 625. X squared minus 6 minus x squared dx works out to be 625 over 6. This is over 48. All right. Sorry about that. Kind of messed that up. All right. Now, I want to real quickly do 2 other problems. And again, the video may cut off. It seems like it gets to about 6 minutes and then it stops. And if it does, we'll just do another one. But problem 2 in your book says this. Let me get it. Problem 2, this is on page page 390, it says that we are going to find the area perpendicular to the x-axis that is found between y is negative square root of x, y is equal to square root of x equals 0, and x equals 4. And then they want me to do a bunch of different things, squares, semicircles, and so on. So first we want to figure out what this looks like. If you graph this, it looks like this. This is y equals square root of x, negative square root of x. From 0 to 4 is through here. All right? And then it says, do these with circular discs where the diameter is in the xy plane. So this actually is a little different than the one we just did. It would be this right here. We want this to be the diameter, and we want semicircles. No, our circles. So we actually want this to go out all the way around. So we're putting circles in that fit, and this is actually the diameter. So the radius is halfway between, and I don't want semicircles. Well, the area of a circle, of course, is pi r squared. R is the difference between these, square root of x minus negative square root of x, which is 2 square roots of x. And the area of a circle then here would be pi times 2 square root of x up. That's the diameter, excuse me. The radius would be then half of that, square root of x squared. So basically this becomes from 0 to 4 pi x dx. And working that out, you're going to end up with pi times x squared over 2 from 4 to 0, 16, 8 pi. Okay? If I did squares, this would be from 4 to 0, and this would actually be my square length, my side, and this then would be 2 square root of x squared, because my side here would be 2 square roots of x, and this then would be 4x squared over 2 from 4 to 0, and that would end up being 16, 64, 32. All right? Now, it looks like my video is still going. The tricky one is number letters C and D. And I'm just going to show those to you real quick. I should have left that up there. I'm sorry. But you can go back and look at it if you want. The next one says that it's squares, but the diagonals are in the xy plane. So they actually have a picture of it for you, but what you've got is this. And they're taking the square, and what they're doing is they're coming out like this. Trying to show it to you is a little bit tricky, but what it would do would be to take this and turn it this way. So it was coming out of the board like this. Okay? So the question is, what is that square? Well, the area of a square is always side squared, but the side we're talking about is this side. No, this side. This is our side squared. So what I need to do is figure out what S would be. If this is side and this is side, remember this is a square, then this length is, let's call this L. L there is, L squared is S squared plus S squared, or L squared is equal to 2S squared, so S squared is L squared over 2. And L happens to be 2 square root of x. Just look at the last problem. So if we integrate this, we're going 4 to 0. 2 square root of x squared dx. And this will end up being, that's s squared, L squared over 2, excuse me. This would be over 2. This would be the square root of x squared. This would be from 4 to 0 x dx, which would be x squared over 2 from 4 to 0. And this ends up having exactly half the area of the previous one. Okay, it looks like my Looks like the video has stopped. No, it looks like it's back on. So one last one, and that is D. And D is a really strange one for students, but what they say is we want equilateral triangles in there. I'm not going to do the whole problem, but an equilateral triangle would look like this. Well, think about it. It's the same thing we just did, almost. But we would say, what is the area here? Area is 1/2 base times the height. So let me draw an equilateral triangle. If I did this, if this is my length, this is half the length. This is also, this is the length. And what we would have to do is the Pythagorean theorem. A, B, C, A squared plus B squared equals C squared. This would be 1/2 L plus B squared is equal to C squared, which would be L squared. And so this is 1/4 L squared plus B squared is L squared. And B squared then is going to be 3/4 L squared, and B then is 3 square root of 3 over 2L. And now my area then will be 1/2. The base here is L times the square root of 3/2 L. And this, the area of this triangle is square root of 3/4 L squared. And so if I was going to integrate, it would go from 4 to 0. I'm going to pull the square root of 3/4 out. L squared dx. Well, what's L squared? It's what we've done before. This would be 2 square root of x squared. And so this actually then, when you integrate it, is square root of 3/4 4x dx. The 4 actually can come out and cancel, and you can solve your problem. So I know that was pretty quick, problems 1 through 9, and watch for the videos for the other one tomorrow. So, all right, thanks, and hopefully we'll see you real soon in April. So.